Didn't work. We'll see. It's not looking at you, it's looking at me. Okay, so solvents, there's always more of, and the solvents do the dissolving, and solutes, there's less of, and they're the thing that gets dissolved. So let's see this in action one more time. Is it going to show us?
Pause. Yeah, go back.
Pause?
Go back.
I think it has to go back.
Back one frame.
Oh.
Back to the
There we go. There they are, breaking apart. Let's go back again. I'm going to pause it. Now, where are the particles from the sugar coming from? Are they coming from way in the middle of the pile?
From the surface.
So yeah, the edge right here, that's where they're being grabbed from. Why are they being grabbed from the edge and not the middle of the pile?
Because of the water.
Colin? Alright, these molecules are all moving around. Why are they moving around? What do they have a lot of? Say it again? Yeah, kinetic energy. They have a lot of kinetic energy. So they're bouncing into each other. And as the water particles bounce or collide into the sugar particles, those sugar particles at the surface there break off. Let's take a look at whatever their info is here. Oh, they labeled it for us. Water particles, the solvent, much more of. Solute particles, sugar particles are the solute, much less of. So solute particles, it says, attract other solute particles. All the water particles are together. And, sugar particles. And then the solvent particles are all together. Why does that happen? We haven't talked about that yet because we haven't really talked about bonds specifically. We're going to in the near future. But this attractive forces, they use this word attract each other, are very similar to the way static electricity works. Anybody ever take a balloon and rub it on their head, then stick it to the side of the wall and it stays there?
Yeah. If you do that to your head,
the water moves too, okay. So why does that happen? It's because of static electricity. There's an attractive force. It's kind of the same thing with these water particles and these sugar particles. They're attracted to one another. When the sugar particles break free into the water particles, they're not changing chemically. Like when we take the balloon and stick it to the wall, while we rub it on our head, does our head change?
No.
No. Does the wall change?
No.
No. Does the balloon change chemically? No. So just like that, none of these particles change their chemistry. It's just a physical break free. They physically break free and move into the solvent particles. Okay, so no chemistry going on, nothing chemical, no chemical reactions. That's why we're able to separate them. Next slide. Oh, it's showing us just that. Here's the edge of the solute, and the solute particles are now attracted to the solvent particles because they're near them. And slowly, the solvent particles collide with the solute particles, and then they move into the solvent.
Looks like a face.
It kind of does. Does that animation help explain how dissolving works? Does it help you visualize what dissolving might look like? You can use this same description or the same visualization for any substance that is dissolving. It doesn't have to be just sugar. Salt would look the same way as it dissolves. Kool-Aid would look the same way as it dissolves. The candy coating, when we had the M&M in the water experiment, that would look the same as it dissolves.
It's like he's being punched.
If you want to imagine it that way, yes. Yeah. Okay. Let's take a look at our homework then, because it's related to a lot of these things. Oh, wait a minute, we can't yet. We didn't look at the other one. Like chalk. We also looked at things that are not that do not dissolve. Right? Because not all substances dissolve. Salt and sugar do. Does chalk dissolve in water? No. Yesterday, were we able to separate it? Did we we separate it from the water? What did we use to separate it? The filter paper, right? So yeah, we can separate the two things. They're mixtures, but the chalk doesn't dissolve. What would that look like? That's it. Those water particles keep colliding with those chalk particles, but they don't break apart. If we wanted them to break apart, what would we have to do?
Mix it.
Yeah, we gotta mix it. We have to stir it, or we can shake the cup around and those particles will disperse. But then if we wait over time, what's gonna happen to those chalk particles? Yeah, they're just gonna settle to the bottom, right? Because they don't dissolve. Cool. Let's take a look at the info on that. So particles, now they threw a new word in there. Particles of insoluble substances do not break free when solvent particles, when solvent particles hit them. No solute particles move into the solvent. So not all things can dissolve, but this new word insoluble, how would you want to define that? It's new, another new word for us.
Oh, I heard of it.
You've heard of it? Insoluble?
Heard of it in 6th grade.
It says particles of insoluble substances do not break free. So how could we define insoluble? How many people read the article yesterday? Thank you, Ben.
Which one?
I did.
You did?
I did.
Okay.
Was
I
it
know the word
actually-
insoluble is in there.
Was it? It was?
Yes.
I didn't do it.
If you read and annotated it, you would have circled this word.
Oh, I remember.
Yeah, I did.
I read it, I just didn't circle it.
Here's what we're going to do then. Here's what we're going to do. Take out your reading packet. Take it out.
Video. I'm gonna find it.
Do you need to borrow one?
So then for exam,
I need to borrow
I
one.
found 2 words I don't know.
You need to borrow one too?
Yeah. What?
Check out yours.
I don't know, is that violent, like, a lot of words, there are a lot of words with X and silent.
Has one? Yep. Okay. Oops. This says electronic.
Any copies of Preston?
Preston, where's yours? Is it in your locker?
I don't know where it is.
Here, so we just use the book. Okay. Page 50, Preston.
Page 49.
What? Page 50.
What is?
We're going to talk about it. Oh, sorry, 49. Page 49.
Oh, that one.
We're going to read it together because there are too many people that did not read it, or at least read it closely. Are we ready?
No, sure not. Wait, no.
Who would like to take that first section, the whole intro section? So that's all the way up to